Hello, hello, welcome back. Today we're going over proportions, one of my favorite things to do in math just because it comes up so many times. It's so useful. Um, and as always, up atop in the blue is the YouTube channel and the email address, so please feel free to hit me up there. But what is a proportion? It's something you may have heard in your everyday life. You know, maybe something is or isn't proportional to something else. It's just a statement of equality between two fractions or ratios in math. That's really all that it is. That's the whole definition. If you're like me and you want to get it even simpler, just think of it as equal fractions. Oh, didn't know I could do that with my pen, but that works. So it's just equal fractions. That's really all that a proportion is. And some common uses when you talk about rate conversion, you're converting, for example, miles per hour to inches per second, whatever. It's proportions are used there. And then in geometry, it's used a lot when you're talking about scale factor, similarity when you're dealing with dilations, all that good stuff. So it is something that is used pretty often. And it's simple enough to do. So proportions, again, equal fractions. So for example, a proportion that we have right here, pretty common one, 5/10 equals 1/2. That's a proportion. Two equal fractions. Simple as that. Okay. I also have a couple of examples down below here. Well, one example, one non-example, I should say. 3 over x equals 9 over 12. Again, one fraction equal to another fraction. That is a proportion. Some of us are thinking, okay, well, why? How do we know it's the same? Because one has an x in it. Well, because there's an equal sign. But that gets into what we're gonna, what we're gonna do in just a second, and that is actually using proportions to solve for unknowns. So that is a proportion, one fraction equal to another. Again, that's an example of one. A non-example right here, if you want to guess why, I'll let you pause. But the reason this is a non-example of a proportion is because we have a fraction that's equal to a whole number plus a fraction. Okay, we have this multiple terms right here. That's not a proportion. We need one fraction on each side of the equal sign. So that is a non-example of a proportion. So not to say that we couldn't make it into one. If we were able to successfully combine 4 plus 2/3, make it into one simple fraction instead of a mixed number or instead of an addition expression right here. But as it stands, it's not a proportion. So a few examples, okay, of how to solve proportions or how to use proportions to solve for a missing variable. Two main ways I'm going to show you. One can be a little bit quicker if you sort of know your factors, and another one is kind of a fail-safe in case you don't. But for example, we have x over 5 equals 14 over 35. So we're trying to figure out, all right, what value of x makes these two fractions equal to each other? Okay, what can I use for that? So one way to look at this is to go, all right, well, the numerators, x and 14. I can't really do anything with that because I don't know what x is. I can't just, solve it just out of the blue. But if I look at the denominators, 5 and 35, if one of those is a factor of the other, in other words, if you can multiply one to get the other or divide one to get the other, depends on how you want to look at it, then you can do the same for the numerators. For example, I know 5 can be multiplied out by something to get 35, and that something is 7. 5 times 7 equals 35. If I have two equivalent fractions, then what I just did to the denominator, I can also do with the numerator to maintain the equality. So I know that x times 7 is going to get me 14. In other words, I just have to ask myself, what times 7 is going to give me 14? Some of you may know that off the top of your head. Go, oh, 2. Easy. So x equals 2. That's fantastic. If you don't know that, we'll just think of this as a way, as a opportunity to take another step. X times 7, that kind of looks like x plus 7. X times 7 equals 14. You could solve it that way. X times 7 is just 7x. And then you could go ahead and solve it out. And you know that x equals 2. So this is going to be 2/5 equals 14 over 35, which is true. You could have also said 35 divided by what gives me 5, and done it that way, and done the same thing. 14 divided by 7 will get me what? In other words, 14 divided by 7 gives me what? You're still going to get x equals 2. Okay, up to you how you want to look at that. Just a couple ways of doing it. And then that's one way to do it. I'm going to show you another method here, and that is to cross multiply. And this is especially helpful when you have situations like this where it's, 3x, or maybe the numbers, let's pretend I didn't know 4 times 2 gives me 8. If you don't know a factor right away that's going to convert, one number to another, you can just cross multiply and you can solve it this way. So I'm going to zoom in a little bit more on this. But cross multiplication just looks like this. 4 times 3x. So I'm going to write it out here just for the simplicity's sake, and we can multiply it out in a second. And then 8 times 12, or 12 times 8, because with multiplication it doesn't really matter the order. You're going to get the same thing. Now we have an equation with no fractions in it. Okay, so that's a lot more helpful. So as always, just need to make sure we simplify both sides. Okay, so we got 12 times 8, we got 4 times 3x. So 12 times 8, 96. 4 times 3x is 12x. And then just divide both sides by 12. We just did 12 times 8, so kind of interesting. So we know that this is going to be 8. Is equal to x, or x equals 8. So again, that's a kind of a fail-safe. There's, if there's a situation where you don't know the factors right off the top, a lot of students that I've seen just like to cross multiply every single time. Pick and choose whatever you want to do. Okay, but cross multiplication can be really helpful when we're talking about situations like this next example. Okay, a word problem. I'm going to change my color up a little bit. All right, if there are 3 boys for every 5 girls in a school, how many girls are there if the school has 402 boys? I don't really care the method that you're going to use to solve this one, but this is just an example of assigning variables. This is an example of, being able to set up a problem. So we want to set up a proportion to be able to help us solve this. So what do we know about the situation, or what do we know about the ratio? Okay, well, the ratio is there are 3 boys for every 5 girls. So that can be expanded out into, larger and larger amounts. So for every group of 3 boys, there's a group of 5 girls. How many girls are there? That's the question. It's important to know what we're looking for too. How many girls are there if the school has 402 boys? Okay, so these are the important pieces of information. So one direct comparison right here is the 3 boys for every 5 girls. So what I'm going to do is I'm going to set up a proportion, boys to girls, based on the ratio and based on the whole student population. So we're going to have, 2 equal fractions. So I know that for every 3 boys, there are 5 girls. So that's the ratio we're going by, 3 to 5. And based on the whole school, well, I know for a fact that we have 402 boys. We've got boys on the boys are the numerator here. And we're wanting to know how many girls are there. So what do you think we're going to do for the number of girls in the whole school? Well, we don't know how many there are. We can give that a variable. In this case, call it x. You can call it g for girls. I don't know. Whatever you like. But now we have a proportion, and now we can solve exactly however we choose to. Now, some of you might not know 3 times what gives me 402 off the top of your head. So, oops, jumped over there. So this is where the cross multiplication really comes in handy. Okay, so right off the bat, 3 times x gives me 3x. 402 times 5, I didn't actually work this one out before I wrote it down, but we're going to do this, is equal to 2010. So 2010 equals 3x. We can just divide both sides by 3. And we have our answer. So 2010 divided by 3 is going to be 670. So let's also make sure we answer the question properly here. How many girls are there? So again, there are 670 girls in the school. So always want to make sure you're telling the, you're using units, all that good stuff. Okay. One other very, very helpful way that proportions are used is to find percentages or portions of those percentages. and I'll show you what I'm talking about. So we know that percentages are out of what number? Out of 100%. Okay, but not everything is going to be perfectly out of 100 every single time. So if we want to find percentages of 100, it's really easy because it's just, hey, 10% of 100 is 10, 15% of 100 is 15. Easy. But when we're talking about other numbers, it's not quite as quick. So proportions are a great way to help us with that. The way that I remember this is just the portion over the whole is equal to the percentage out of 100, because that's really all that percentages are, is portions of 100. But we just have to set it equal to, a new whole. We're not always looking out of 100. So when these are written out, you can think of it as is and of. If you read the question, what is this number is, if that's the portion, of is going to be of this much of, the new whole. So is over of equals percent over 100, or just the portion of the whole is equal to the portion of the whole. It's just percent over 100 when we're talking about percentages. So keep that in mind. So example number 1, what is 14% of 670? Well, let's just set up our proportion. 14 is the percentage. I know that's always out of 100, so that's the first one I always set up because percentages is always out of 100. And then it's easier to kind of figure out what the rest of this problem is. Of 670, that's going to be the new whole amount. And then what is? So when I have a question like this, that's my variable. That's what I'm trying to solve for. Simple as that. And then just like always, we can solve our proportion. I'll do it by cross multiplying. Let me move this up just a little bit. Okay, cross multiplying, we have x times 100, that's 100x. And then 14 times 670. I don't trust my own head to do that very quickly. Is going to be 9380, 9,380. Divide both sides by 100 to get x alone. And then when we divide by 100, we're essentially moving the decimal point over 2 spaces. So this is going to be 93.8. So that answers the question. What is 14% of 670? 93.8 is equivalent to 14% of 670. Okay, makes sense that it's larger than 14 because we're looking out of a larger portion than 100. Okay, if it was a smaller portion, if it was a smaller whole than 100, then it'd be a smaller than 14. Okay, that would also be proportional. And last but not least, we'll try one more example. 273 is what percentage of 350? So again, I'll write this down here so you can see. Again, portion over whole, or is over of. Okay, let's set up that proportion. What percentage? We are missing the percentage, so that's going to be our x. All we have now, 273 is what percentage of 350? Well, 350 is obviously the new whole because that's what we're looking at. And then 273 is what percentage of 350? Not to say that it, the bigger number is always the whole. Sometimes we're looking at something that's over 100%. Haven't really done an example like that here, but just so you're aware, doesn't always have to be a proper fraction, could be an improper fraction. So we'll go ahead and multiply. 350 times x is 350x. And then 273 times 100, 273. If you're multiplying by 100, you just add a couple zeros. There you go. And then we're going to divide both sides by 350. So 27,300 divided by 350 comes out to be 78. So in this case, 273 is 78% of 350. Okay. Again, makes sense because 273 is not as large as 350, so we know it's got to be a smaller number than 100. If you've got something bigger than 100, something's up. Okay. Again, you should always have two improper fractions or two regular fractions. Again, thinking of proportionality needs to make sense, right? Always ask yourself, does my result, do my answers make sense? So hopefully that helped. Definitely feel free to hit me up if you have any kind of questions, but I, again, hope that was helpful.